All right, today we're going to be simplifying radical expressions, and radical just simply means it's got a square root. Expression means a number or variables without an equal sign. Okay, so by definition, I'm going to zoom in here on radical expression here. And by definition, an expression that contains a square root. All right, and so we're looking here, we can see that we have the square root of AB. Okay, and what you just really kind of need to understand that this is just really saying the square root of A times the square root of B. If I were to go backwards when I'm looking at a number here, I could call this the square root of 36, and then hopefully we know that the square root of 36 would just be 6. Okay, so again, though, a radical expression can either have variables or it can have numbers, and it's just got to be inside a square root. Okay? All right, and looking down here on number 1, when we're simplifying a square root, we are simply going to make what's called like a factor tree. And we're going to just start breaking this down into prime numbers. So like 52 is even, so I know 2 can go into it. 52 divided by 2 is 26. All right. Now 2, this guy is as far as it can go, but the 26 can still be broken down to 2 and 13. And what I'm looking for are pairs. Okay. So here I have a pair of 2's, and if it has a pair, that's going to move to the outside, and then whatever I have left over, in this case the 13, stay stuck on the inside. Okay, so again, pairs are on the outside. What numbers are not left, do not have pairs, then go on the inside. All right, so let's look at example 2 here. On example 2, you've got to break down 80 into 2 and 40. I can break it into 40 into 2 and 20. 20 I can break down into, let's say, 4 and 5. And 4 will go to 2 and 2. All right. Now you can break this down many ways. You could have went like 8 and 5 and all kinds of things. So you may not do the exact same breakdown as I do, but hopefully you end up with the same answer at the end. All right, so now we're going to look for pairs. All right, so I have a pair of 2's here, and I have a pair of 2's here. Okay, so now when I'm coming up with a final answer here, I'm going to have 2 times 2. Remember, everything with square roots is all about multiplication, okay? So I'm going to have 2 times 2, because those are my pairs, 2 times 2. So 2 times 2 is 4. That's going to go on the outside. And whatever I have left over, and in this case it'll be a 5, will go on the inside. Okay? Now, keep in mind, I don't want to see anything with like 40. Once you break it down, it's like out of the game. So like you can't use the 40 once you break it down. The 40's gone, the 20's gone, the 4's gone. So you can't have that show up in your final answer. It's just going to be what's on the ends is what we need to figure out. Does it go on the outside or the inside? Okay? All right, so let's look at example 3. All right, so now this one already has a number on the outside. Not a big deal though, because we're still going to go ahead and just break down the 180. Okay? And so let's say this time I'll change it up a little bit and I'll do 10 and 18. Okay? 10 will break to 2 and 5. 18 will go to 2 and 9. And then that 9 can keep on going to 3 and 3. So again, looking for pairs, I have a pair of 3's and I have a pair of 2's. Okay? And then this 5 is the leftover. Okay? All right, so now, since I already had this 2 on the outside here, I have to take that into consideration. So I'm going to multiply the 2 here, the pair of 2's here, and the pair of 3's here. Okay, so on the outside, I'm going to have 2 times 2 is 4, times 3 is 12. On the inside, I have a 5. Again, this number comes from, right here I have a 2, so 2 times, then I have a pair of 2's and a pair of 3's. Oh, so times 2 times 3. That's where that's coming from. Okay? All right. Number 4. Okay, so now you see here, it's just a multiplication problem. You're simply just going to multiply it first and then break it down. So 2 times 24 is 48. And now I'm going to break down 48. Okay, I'm going to use 6 and 8. The 6 will break to 2 and 3. The 8 will break to 2 and 4. And 2 and 2. So the 2's are going to pair up. And these 2's are going to pair up. Okay, so 2 times 2 is 4. And then I have this leftover 3 right here, radical 3. Okay, and we realize that radical is just another word for square root. In fact, that's what you're going to usually hear me call it. Okay, so on this case, again, 2 times 2 is 4, 3 over on the inside. All right, let's try another one here. Okay, on number 5, I have got 2 radical 45. Okay, I only multiply the outsides and the inside. So here I have a 2 on the outside. Technically there's a 1 here, that's why 2 times 1. And then I'm going to multiply the insides, 3 and 15. Okay, so you can only multiply what's on the outside together and then what's on the inside together. You cannot interchange them. Okay, all right, so now I'm going to be breaking down the 45. And I've got 5 and 9. And 3 and 3. 3's pair up and move out. So now don't forget about that 2 already out there. So on the outside I've got 2 times the 3, which is 6. And then I have this 5 left over. So radical 5. Okay. All right. Example 6. Okay. So I'm going to multiply the outsides again together first. So 3 times 4 is 12. And then I'm going to multiply the insides. And on the inside here, I've got the square root of 100. Now, in this case, I know what the square root of 100 is. I am not going to break it down with a factor tree. You can do it if you want. So, like, you can say, okay, 10 breaks to 10, or sorry, 100 breaks to 10 and 10, pairs 10s, moves out, okay? I normally just look at it and say, all right, well, 12, the square root of 100 is 10, so what's 12 times 10? And in this case, that would be 120. And that would be your final answer in this case, okay? Let me erase that real quick. All right, let's move down and look at example 7. Okay, so example 7 says a rectangle has a width of 3 root 5 centimeters and a length of 4 root 10 centimeters. Find the area. All right, and we know that area is length times width. So area equals 3 root 5 times 4 root 10. Okay. All right, so 3 root 4 is 12. Or sorry, 3 times 4 is 12. And then 5 times 10 is 50. Again, multiply the outsides together and multiply the insides together. Now 50 can be broke down to 2 and 25. And 25 goes to 5s. 5s pair up and move out. So on the outside here, I've got 12 times the 5 is 60. 2, this 2 is left over, so root 2. So that would be your area. All right, now there is one little side note here that I forgot to kind of put in the notes, so let's just kind of call this for right now example 8. Let's see, where am I going to put it? Here, I'm going to put it right here, example 8. Okay. We need to take a look when we have more than one part left over on the inside. So let's say I have the square root. Trying to think off the top of my head, guys. Give me a second. Let's say 120. Let's see if this works out for us. Okay, so as I break it down, I'll get 2 and 60. And then I'll say 6 and 10. This will go to 2 and 3. And this will go to 2 and 5. Okay, so as I look for pairs here, I have a pair of 2's, but nothing else will pair up. Okay, so I have a 3, a 2, and a 5 all left over. Okay, so when that happens, still the same concept. Pair of 2's moves out, so 2 on the outside, and you're going to multiply all of those box numbers. So you're going to multiply the 3, the 2, and the 5 all together. Well, 3 times 2 is 6. 6 times 5 is 30. So I'm going to end up with 2 root 30. All right, and that concludes today's notes for you.